Hello everyone and welcome back. This is going to be the last chapter that we cover before the end of year assessments. So this week we're going to cover chapter 19.1 and 19.2. And then next week we're going to have kind of a catch up on any missing work. You'll have time to review. And then the following week will be your end of year assessments. So that's exciting news, and then you guys will be able to enjoy hopefully a fun and exciting summer vacation, especially after all this crazy drama that we've been going through this last several weeks. All right, so let's look at chapter 19, and we're going to be talking about waste management. So chapter 19.1, which we'll cover for Monday and Tuesday's lecture, is discussing municipal and industrial waste. So out of all the solid waste that is produced in the United States, there is approximately 34% of it made up of paper. And so our guiding question for this section is going to be, how does our current waste disposal impact our environment? Just like we start out every section, we are going to look at what it is that we should be able to know or answer at the end of the section. So we should be able to identify the 3 categories of waste, and then we should be able to describe conventional waste disposal methods. Go ahead and turn in your workbook to 19.1 and complete the vocabulary, which is waste, municipal solid waste, industrial waste, hazardous waste, sanitary landfill, leachate, and incineration. The definitions are available to you on LMS. I've posted the answer key for the workbook, so you can follow along with your classwork, participation, assignments as well. And it's also been emailed out to you or to your parents if you did not have your email set up. So when you're done with vocab, come on back to the video and we'll keep going. So do you ever think about all the items that you throw in the trash every day? A paper napkin, an empty yogurt container from breakfast, the contents of your lunch tray at school, or the empty water bottle or apple core from an afternoon snack. And those are just items related to, things that we eat or meals. How about the plastic wrap that surrounds the news magazine, or those dried up pens or markers you threw away in class? The list is probably much longer than you ever imagined. Now think about the other people who live in your house, your city, and then your town. Suddenly, the amount of garbage becomes overwhelming. So let's talk about waste. What is it? Well, it's any unwanted material or substance that is a result from human activity or processes. So it's just from the things that we do in our life, anything that is left over and unwanted from those activities is considered waste. So as the world's human population increases, and as we produce and consume more goods, we end up generating more waste. So let's define waste. For the purpose of this chapter, waste is the unwanted material or substance that results from human activity or process. Waste pollutes our water, air, and soil. It's ugly to look at, and it's even worse to smell. In order to safeguard public health and protect the environment, we need safe and effective waste management. In this lesson, we're going to learn about where our waste comes from and then where it ends up. There are three main categories of waste. The first is municipal solid waste. This is non-liquid waste that comes from homes, institutions, and small businesses. The next kind of waste is industrial waste. Industrial waste is waste that comes from the production of consumer goods, from mining, during agriculture, and during petroleum extraction and refining. And the last category of waste is hazardous waste, which refers to solid or liquid waste that is toxic, chemically reactive, flammable, or corrosive. It includes everything from paint and household cleaners to medical waste and industrial solvents. Another type of waste is wastewater. Wastewater includes the water we use in our households, businesses, industries, and public facilities. It also includes the things that go down the drain, we flush down our pipes, as well as the polluted runoff from our streets and in our storm drains. In this chapter, we're going to limit our focus to the three main categories of waste, which were municipal solid waste, industrial waste, and hazardous waste. So let's talk a little bit more about municipal solid waste. It is waste that is produced by consumers, public facilities, and small businesses. It is what we commonly refer to just as trash or garbage. Everything from paper to tires to food scraps to roadside litter, even old appliances and furniture are considered municipal solid waste. In the United States, paper, yard debris, food scraps, and plastics are the main components of solid waste. Even after recycling, paper is the largest component of U.S. municipal solid waste. The average American generates more than 2 kilograms, which is about 4.5 pounds of trash per day. And that amounts to about just over 1,600 pounds per year. So let's take a look at our chart here. We have municipal solid waste, and we can see that it's divided up into different categories representing how much trash each item represents. So paper, out of all the things that we throw away from our homes or our small businesses, paper makes up 33.9%. Yard trimmings would come in at the next largest contributor at 12.9%, followed by food scraps at 12.4%. Plastics makes up the next most, the fourth most, with 11.7%. And then we have metals, rubber, wood, glass, and then other miscellaneous. So we have packaging and non-durable goods. So let's talk about what makes up a large chunk of that municipal waste. Municipal meaning, remember, that it comes from our homes or our small businesses. So a large portion of municipal solid waste comes from packaging, or what we call non-durable goods. Packaging includes bubble wrap, blocks of styrofoam, and packing peanuts. Non-durable goods are products that we discard after a short period of time. Non-durable goods includes items such as pens, disposable cameras, clothing, even some furniture. We can also include things like razor blades in there. Anything that you're going to use for a short amount of time before you dispose of it. In addition, we throw away old durable goods and outdated equipment as we purchase new products. For example, do you know someone who got a new cell phone just because their contract had expired, or because the new model of their favorite phone came available? The old cell phone was probably good and still working, but the person wanted something new. And as we acquire more goods, we end up generating more waste. Plastic products. During the 1970s, plastic products became widely available to consumers. They were inexpensive, non-durable goods. Most plastic products were made for temporary use. They wore out quickly and soon piled up in dumps. Since the 1970s, plastic products have accounted for a significant increase in solid waste. So just a reminder, which type of material is the largest single contributor to municipal solid waste? To answer that, we'll go back to our chart, see which one makes up the largest percentage, and it's paper. And we see paper waste shown here. Of course, this is if the waste is separated out into paper and plastic. Packaging waste is all kind of mixed together, right? It could be metal, it could be plastic, it could be paper products, and this would be what our recycling bins at home would look like. So we talked about municipal solid waste. That was our first of our three types of waste that we're going to be talking about. Our next is industrial waste. So the U.S. Environmental Protection Agency, or the EPA, classifies industrial waste as waste that is neither hazardous nor does it fall into the municipal solid waste. So industrial waste includes waste from factories, farms, mines, or refineries, as well as all the material from large construction sites. Industrial waste can also include medical waste, such as used surgical gloves or needles that have been used for drawing blood or giving injections. Each year, U.S. industrial facilities generate about 7.6 billion tons of waste. Almost 97% of that waste is wastewater. The rest is solid waste, about 228 million tons. This amount almost equals the amount of municipal solid waste we dispose of each year. Most of the time, private companies collect and dispose of industrial waste. The third category is hazardous waste, which is toxic, reactive, flammable, or corrosive. Remember, things that fell into that category could be batteries or paint, as well as blood contaminated products from the hospitals or things like that. And then, of course, they did talk about wastewater as a fourth mention, which, of course, was just water that is either flushed down our drains, that's runoff from our sewer or our roads, or into our sewer drains. All right, guys, that's going to be it for Monday's lecture. So go ahead and stop here and complete in your workbook chapter 19.1, number 1 through 10. Also, make sure that you have completed the vocabulary for this section. And when you're ready, you can come back and finish up 19.1. All right, hello everyone, and welcome back to Tuesday's lecture. We are finishing up chapter 19.1, Municipal and Industrial Waste. So we're going to talk about methods of solid waste disposal. So historically, people dumped their garbage wherever it suited them. As cities and towns became more and more crowded, and garbage started piling up, local authorities took on the task of consolidating trash into open dumps, which was specified locations that everyone agreed the trash would be placed to keep the other areas clean. To decrease the volume of trash, those dumps would be burned from time to time. Of course, burning the waste will reduce the amount of space that waste will take up because the waste gets broken down. Open dumping and burning still occurs throughout much of the world, and as populations and consumption rise, waste is increasing and dumps are growing larger. As cities and suburbs expand, more people end up living next to dumps. These residents are repeatedly exposed to harmful, toxic, and foul-smelling smoke from dump burning. As a result, more people are aware that unregulated dumping and burning damages their health and degrades the environment. In response to these hazards, many nations are improving their methods of waste disposal. Most industrialized nations now bury waste in landfills or use incinerators to burn their waste. So as you can see in the picture, we have something that's called a sanitary landfill. So in modern sanitary landfills, waste is buried in the ground or it's piled up in large, carefully engineered mounds. In contrast to open dumps, sanitary landfills are designed to prevent contamination of groundwater and to reduce soil and air pollution. Most municipal landfills in the United States are regulated locally or by the state, but they must meet national standards that are set by the EPA. We can see parts of the sanitary landfill in the figure on your screen. In a sanitary landfill, waste is partially decomposed by bacteria and then compressed under its own weight to take up less space. Waste is layered along with soil, a method that speeds up the decomposition process. It also reduces odor and reduces infestation by pests. Some infiltration of rainwater allows for biodegeneration by different types of bacteria. However, if too much water gets in, some contaminants may escape as the excess water flows out. So to protect against environmental contamination, the U.S. regulations require that landfills be located away from wetlands or from areas that are prone to earthquakes. And they also have to be at least 6 meters or 20 feet above the water table. The bottom and sides of the sanitary landfills must be lined with heavy-duty plastic and about 2 to 4 feet of impermeable clay to help prevent contaminants from seeping into the aquifers. Sanitary landfills must also have systems of pipes installed and collection ponds. They also have treatment facilities to collect and treat the leachate. The leachate is a liquid that results when substances from the trash dissolve in water as rainwater percolates or trickles downward. Landfill managers are required to maintain leachate collection systems for 30 years after the landfill has closed. Regulations also require that area groundwater be monitored regularly for contamination. So let's talk a little bit about some of the benefits and cost of landfills. So what happens to a landfill after it's closed? After a landfill is closed, it is capped with an engineered cover that must be maintained. This cap actually consists of a hydraulic barrier of plastic that prevents water from seeping down and gases from seeping up. It also has a gravel layer above that hydraulic barrier that drains water. It lessens the pressure on the hydraulic barrier. A soil barrier of at least 2 feet that stores water and protects the hydraulic layer from the weather extremes, and a topsoil of layer of about 6 inches that encourages plant growth and prevents erosion. Today, thousands of landfills lie abandoned. One reason is that waste managers have closed many smaller landfills and consolidated the trash into fewer, much larger landfills. In 1988, the United States had nearly 8,000 landfills, but today it has fewer than 1,700. Some landfills have actually been converted to recreational areas. So when landfills are closed, they typically become a public park or recreational area. So let's look at the drawbacks from landfills. Despite improvement in technology, many experts believe that leachate will eventually escape even from a well-lined and well-maintained landfill. Liners can be punctured and the leachate collection systems eventually cease to be maintained. Moreover, landfills are kept dry to reduce leachate, but the bacteria that break down material thrive in wet conditions. Dryness therefore slows waste decomposition. In fact, it is surprising how slowly some materials biodegrade when they are tightly compressed in a landfill. Innovative archaeological research has revealed that landfills often contain food that has not been decomposed and 40-year-old newspapers that are still legible. That's pretty disgusting. Another problem is finding suitable areas to locate landfills. Because some communities do not want them nearby, this is a kind of not in my backyard mentality. It explains why residents of states receiving that waste are increasingly protesting. As a result of the NIMBY, or not in my backyard syndrome, landfills are rarely located in neighborhoods that are home to wealthy or well-educated people that have political clout to keep them out. But what's a benefit? We can actually capture energy from landfills. So deep inside landfills, bacteria decompose waste, and because it's an oxygen deficient or anaerobic environment. This anaerobic decomposition produces landfill gas. It's a mixture of gases in which almost 50% is methane. We can actually collect, process, and then use landfill gas the same way we use natural gas. At Fresh Kills Collection, wells pull landfill gas upward through a network of pipes by vacuum pressure. The gas is tapped and then can actually provide enough energy for 25,000 homes. So just to review, the benefits are that we get methane, which can be used just like natural gas to create energy. And then landfills, once they are no longer being used, can be capped and covered and used for recreational areas. The costs of landfills is that it produces that disgusting liquidy waste goop, leachate, which may eventually escape, and that would contaminate the surrounding area and potentially contaminate the aquifer or groundwater. The trash decomposes very, very slowly. Remember, even having newspapers that were 40 years old that you could actually still read. And then, of course, few communities are willing to have landfills in their area, which limits where they can be placed. So we mentioned that when the waste builds up, that we actually burn the waste off. And that's done through incineration. So just as sanitary landfills are an improvement over open dumping, incineration is specially constructed facilities that can improve over open air burning of trash. So incineration is a controlled process in which a mixed garbage is burned at very, very high temperatures. Pollution controlled technology removes most, but not all, of the pollutants from the emissions. At incineration facilities, waste is generally sorted and metals are removed. Metal-free waste gets chopped into small pieces so that it burns more easily. Incinerating waste reduces its weight by up to 75%, and it reduces its volume by up to 90%. As a result of real and perceived health threats from incinerator emissions and of community opposition to these plants, engineers have developed several technologies to mitigate emissions. They have something called scrubbers, and this chemically treats the gases produced in combustion to remove hazardous components and neutralize acidic gases, such as sulfur dioxide and hydrochloric acid, turning them into water and salt. Scrubbers generally do this either by spraying liquids formulated to neutralize the gases or by passing the gas through dry lime. These scrubbers are similar to the ones used to treat smokestack emissions from coal-fired plants. Particulate matter is physically removed from incinerator emissions in a system of huge filters known as a baghouse. These tiny particles, called fly ash, often contain some of the worst dioxin and heavy metal pollutants. In addition, burning garbage at especially high temperatures can destroy certain pollutants, such as PCBs. Even all of these measures, however, do not fully eliminate toxic emissions released during the process. So just like everything, there is cost and benefits. So our benefits, of course, were the fact that incinerating the waste reduced the weight and the volume of the waste before it needed to go to the dump. And then heat from burning the trash can actually be used to generate electricity. So waste to energy. But what are the costs? Simply reducing the volume and weight of trash does not get rid of all the toxins, right? The ash remaining after trash is incinerated, therefore must be disposed of in hazardous waste landfills. Moreover, when trash is burned, hazardous chemicals, including dioxins, heavy metals, and PCBs, can be created and released into the atmosphere. Such releases can cause a backlash against incineration from citizens concerned about health hazards. Most developed nations now regulate incinerator emissions, and some have completely banned incineration outright. So the cost is the toxic ash and releasing of dioxins, heavy metals, and PCBs into the atmosphere. It would be interesting to see some studies on, or statistics, especially in the areas that have banned the incinerators. So, I mentioned that we can get heat from the I mentioned that we can get energy from the incinerators, but so how does that actually work? Incineration was initially practiced simply to reduce the volume of waste, but today it serves as a way to generate electricity as well. Most North American incinerators today are waste to energy, or WTE, facilities. These incinerators use the heat from burning waste to boil water. The boiling water creates steam that then drives a generator to make electricity. Steam from the incinerators can also fuel heating systems. Burning waste equals almost 35% of the energy from burning coal. Revenues from power generation, however, are usually not enough to offset the financial cost of building and running incinerators. Because it can take many years for the WTE facility to make a profit, many companies that build and operate these facilities require municipalities to guarantee a minimum amount of garbage. On occasion, such long-term commitments can defeat efforts to reduce waste through recycling because towns are required to guarantee a certain amount of trash to those facilities. All right, guys, that finishes up 19.1. Go ahead for classwork and turn to 19.1 and complete numbers 11 through 15 in your workbook. And then your homework tonight is available here in your textbook or on LMS. And it is 19.1, Lesson 1 assessment, just 3 questions. All right, guys, have a good night, and I will see you in the next lecture on 19.2 when we are going to be talking about how to minimize our solid waste.